In Lesson 3, we begin to discuss equivalent ratios. So let's try out an example problem so that we can learn about how to find equivalent ratios. The problem states that for every $2 that Cam saves in his account, his sister saves $3. The question asks us to determine the ratio of money in Cam's account to the money in his sister's account. And since order is important, Cam's account has to become before his sister's account. So Cam saves $2 to every $3 his sister saves. So the ratio is 2 to 3, or we can write it as 2 to 3. So I'm rewriting the ratio on this page. And the question is asking us, if Cam has $60 in his account, how much money does his sister have? To solve this, I'm going to do a tape diagram. So let's draw out the ratio. So there are $2 to every $3 that his sister saves. So this is Cam, and this is the sister. Now, we know that Cam's total amount in his bank account is $60. That means that if we take the 60 and split it into two pieces, each piece is worth 30. So if each piece of the account is worth 30, there's two pieces, that makes $60. Now, if the ratio is to hold true, that means each of these blocks down here, each of the pieces of the tape diagram, is worth 30, and we need to know the total amount that the sister has. So if we know how much each individual block is worth, we can solve this problem by adding up 30 plus 30 plus 30, which gives us 90. So that means his sister has $90 and he has 60. The problem on the next page tells us to record the equivalent ratios. So we can record them as 2 to 3. And if we recall, Cam had $60 and his sister had $90. And what we'll start to learn is that there is a constant that we can multiply each side of the ratio by to get the equivalent ratio. So if we notice, how do I get from 2 to 60? And how do I get from 3 to 90? What can I multiply by? Well, it might be easier to see it in the 2 to 60, but I'm multiplying by 30. And notice that that 30 that I was multiplying by is how much each piece of the tape diagram is worth. And if you notice, I can multiply on the other side by 30. That makes these ratios equivalent. There's a constant that I can multiply by to get from one ratio to the other. And furthermore, we can create an infinite amount of ratios by just picking a number to multiply by. So I could say, let's pick a different color so you can see, I want to multiply by 6 on both sides. 2 times 6 gives me 12, and 3 times 6 gives me 18. So 12 to 18 is equivalent to the ratio 2 to 3.